Welcome to the video notes for Module 11, Part 1, an introduction into random variables. We're going to consider first an example where we toss two coins. So the first thing we want to do is list all of the outcomes you can have when you toss two coins. So for example, you could have a heads and a heads and a tails and a heads, and finally a tails and a tails. So these are all of the possible outcomes. So I've created the sample space for tossing two coins like we would have done back in modules 8 and 9. But now when we're looking at this in terms of a random variable, instead of looking at what the outcomes are, we're going to specifically look at, we're going to let x represent the number of heads that we get from tossing two coins. Okay, so instead of x being, do we get two heads or whatever, well, that is what x is going to be. So the possible values I have for x is I could have 0 heads, I could have 1 head, or I could have 2 heads. So the probability that I get 0 heads is going to be 1 out of 4, which is 0.25. Because up here, out of my 4 outcomes, there was one time where I didn't see any heads. The probability that I get a single head is going to be 2 out of 4. Because up above we can see 2 times where we flip the coin 2 times and we only got 1 heads as a result. So it's this one and this one. And then finally, 2 heads is going to be 1 out of 4, 0.25. So what I've created right here is a discrete probability distribution. It's discrete because the values of x over here, the 0, 1, and 2, are discrete values. Okay, I couldn't have half of a heads, or I couldn't have 0.579632712 heads. Okay, I could have 0 heads, 1 head, or 2 head. So it's a countable number of outcomes. And then I found the probability for each of those outcomes, and if I sum all of these up, it sums to 1. So I have a probability distribution here, where I've listed x is the number of heads that I saw, and p of x is the probability that I saw that many heads. So this is the basic idea of what we're going to be doing for the rest of this section. So once we have a discrete random variable, or when we have a discrete probability function, we want to find the mean. So looking back up at this first example, what is the mean number of heads that I would expect to find if I flipped the coin 1,000 times? So the mean of a discrete random variable is found by, it's always a mu, and it's going to be the sum of each x times the probability of that x. That is how we're going to find the mean of a discrete random variable. So we're going to go ahead and do that with this example. So John and Alyssa are doing a survey about the students around campus. They ask about their ages, and their findings are in the probability distribution below. So you have the variable x is their age, and then the probability that they found somebody of that age. So the probability they found someone that was 18 was 0.13, probability of a 19-year-old was 0.14, and so on and so on. So we're going to go ahead and find the mean age of the students around campus. We're going to do it by hand here in the notes, and then there'll be an accompanying calculator video that you guys can watch, and I'll show you how to do this in your calculator very quickly that you'll be able to use for future assignments and your exam. So we're going to go ahead and find the mean. So we're going to do that by taking each x value, so 18 times its probability, 0.13, and adding all those together. So plus 19 times 0.14 plus 20 times 0.12 plus 21 times 0.11 plus 22 times 0.12 plus 23 times 0.16 plus 24 times 0.09 and plus 25 times 0.13. Kind of ran out of room there. Okay, so when I do this, this is going to give me the mean. Now you can type this into your calculator exactly as you see it here, all in one step. So long as you have those parentheses to show the multiplication, your calculator will do it correctly. Okay, so when we do this, we get a mean of 21.44. So this means the mean age of a student on campus is 21.44 years old. This value is also known as the expected value. This means if we were to randomly select a student on campus, we would expect them to be 21.44 years old. So the mean and the expected value have the same meaning and they are calculated the same way. I'm going to say that one more time. The mean of a probability distribution, what we found up here, the mean age, and the expected value are the same thing, and they are calculated the same way. They're just interpreted a little bit differently. Okay, the mean says the average age of the students on campus is 21.44. The expected value says if we randomly select a student on campus, we would expect that student to be 21.44 years old. But the calculation to find these two values is always going to be the same. So now we're going to look at the standard deviation of a discrete random variable. Now this guy we're not actually going to calculate by hand. I'm only going to do it using technology, which you will see in the technology feature. But I am going to go ahead and show you the equation for it. So the equation for the standard deviation, it's always going to be a sigma, and it's the square root of the sum of each x minus the mean squared times the probability of that x value. And that whole thing gets put underneath the square root. So we are going to go ahead and find the standard deviation of the probability distribution from the previous example, which I'm actually going to have to go back up to it. Okay, and like I said, there will be a calculator video that shows you guys how to do this. If you would like to try and calculate it by hand, you are more than welcome to, but I am not going to cover that. So give me just one second. I was not fully prepared this time. All right, so our standard deviation for the ages of these students on campus is equal to 2.3036. Okay, and that standard deviation is interpreted just like we've interpreted standard deviation in the past. This is a measure of spread. Okay, and it's telling us on average how far the data points are from the mean. So on average, a person is about 2.3 years under or over that mean we found of 21.44. Okay, so far we've looked at a probability distribution. We've looked at how to form a probability distribution, very briefly. We looked at how to calculate the mean, how to interpret the mean as an expected value, and then finally how to find the standard deviation. So the last thing I'm going to cover in these notes is looking at a very specific example of an expected value problem. And this is one that is used in the real world a lot, and it's not always very clear on how to solve it. So I definitely wanted to go over one of these with you guys. So we have a term life insurance policy that will pay a beneficiary a certain sum of money upon the death of the policyholder. So for example, if your parent has a life insurance policy and you are their beneficiary, when they pass away, you will get however much money they were paying into that policy, or how much money that policy was worth, rather. These policies have a premium that must be paid annually. So every year, your parents have to pay into this account in order to keep their life insurance policy. Okay, so an 18-year-old male bought a $250,000 one-year term life insurance policy. So this 18-year-old was like, you know what, I'm going to go do some super dangerous stuff for the next year. I'm going to go ahead and take out a one-year life insurance policy. That way, if I die doing this super dangerous stuff, my family is not totally screwed. Okay, the probability that the male will survive the year is 0.998937. So compute the expected value of this policy to the insurance company. So how much is the insurance company expecting to make on this type of a life insurance policy? So what we're going to do is we're going to set up this example with a table. We're going to do an X column and a P of X column, just like we had for the dice roll at the beginning. Now there are only two possible outcomes for this 18-year-old male. He could live or he could die. So we know the probability that he dies is 0.998937. And we can use the complement rule to find the probability that he lives, which is the probability that he lives is 0.998937. The probability that he dies is 0.001063. So this is the probability that he dies, and this is the probability that he lives. If he lives the full year, the insurance company does not have to pay any money, but they earned the $350 that he paid up front. Okay, so he paid $350. So the life insurance company will get that $350 if he lives, and then they don't have to pay anything. So if he lives, the insurance company makes $350. If he dies, however, the insurance company has to pay his family the $250,000 minus the $350 that they made. So when they start the year, they have a profit and a loss of 0. Then this 18-year-old pays them $350, so now they're ahead $350. But then let's say 6 months later he dies, so they have this ahead of $350, and now they're having to pay the $250. So they actually have a loss of negative, I did not leave myself enough room, 249,650. So if the 18-year-old dies, the insurance company is going to lose $249,650 because they're having to pay his family. If the 18-year-old lives, then the insurance company is going to make $350 because they're not going to end up having to pay anything. So this is how we're going to set up the table for a problem like this. And now we're going to go ahead and find the expected value or the mean for this policy. So I'm going to take the $249,650 and I'm going to multiply it by the 0.001063 plus 350 times 0.998937. And I get an expected value, which I can write as e to the x, or e of x, is equal to 84.25. So what this means is for the insurance company, for a life insurance policy like this, they can expect to make $84.25 over all of these policies. They're not going to make $84.25 on this one male. They're either going to pay or they're going to make money off of him. And it's either going to be the $249,650 or the $350. But if they were to look at all of their 18-year-old males who have a one-term life insurance policy, they can expect to make $84.25 at the end of the year for all of the males that have this policy. So this $84.25 is not on an individual basis, it's an average for all of the 18-year-old males that have this type of life insurance policy. So I definitely wanted to do one of those because, as you can see, it can be a little bit confusing how to set up the table and what that means. But then the math is just like what we did up above. We multiplied these numbers together and then we added the results. And that's how we got to the 84.25. So that is actually it for Module 11, Part 1. Pretty short section. And I'll see you next time.